All right, so just deciding if a tennis ball is bad, it's basically all about the bounciness. So they can be too bouncy or not bouncy enough. And then to make that decision, I assume you just looked at the height of the bounces when you were deciding. So I just looked at what the International Tennis Federation's rules were for a correct ball, and it needed to bounce back between 53% and 58% of the original height. So I just took 56%, and I just multiplied by 0.56 each time to get this one. You might not have been able to get those exact heights on the little Desmos activity. But anyway, you probably got something close to those. And then that's what the graph would look like. And then what type of function does that look like? Exponential. And that's what we're getting ready to talk about. Unit 4 is on exponential and logarithmic functions, which you did learn about in Algebra 2. They're actually learning logarithmic functions right now in Algebra 2. So about this time last year, you were learning kind of the same thing. We'll obviously do some different things than you did last year. And then you, on Desmos, you use your points. You made a function out of it. So I'm going to make the actual function for mine. And so it would be y equals, and then you would put a 4. Now, you might not have had exactly a 4, but why do you think the answer is 4? It's the initial height where you dropped the ball from originally. And then if I'm multiplying by 0.56 each time, then that should be what's in the parentheses, and it should be raised to the x. That's what an exponential function is going to look like. The variable is going to be up at an exponent. That's why it's called exponential. Where 4 is the initial height, like at bounce 0, before it bounced, that's the height. And then 0.56 is the, I guess, percentage of bounce back. Well, that's how much was left. So it lost 44% and bounced back 56%. I don't know if that's a good word for it, but it's fine. How'd you guys do deciding on good and bad? Pretty good? Pretty bad? I didn't do great when I was first doing, like, I was doing it real fast. I didn't do great on deciding good or bad, but it's fine. All right, so if you wanted to give advice to someone, I don't know if I saw any of you using the calculator, which is fine, but you could just like calculate, like multiplying by something each time, like I did on my table. But all right, so let's look on the other side. And like I said, we're getting ready to talk about exponential and logarithmic functions, starting with exponential. All right, and exponential functions are of the form y equals a, and then in parentheses we have b, and then that's raised to the x. All right, so what do you think a is going to be? Yeah, a is initial, we'll call it initial value. I'm going to put it at time 0. And b is the growth or decay rates. All right, and so these functions in that form are going to be exponential growth when a is positive. So if a is negative, it could be some type of growth or decay. It's not necessarily going to be exponential growth or decay. So for us to say something's exponential growth, that number in front needs to be positive, and then B also needs to be greater than 1. So B also needs to be positive. All right, and then for exponential decay, A also needs to be positive again. And this time B needs to be between 0 and 1. So a fraction or a decimal between 0 and 1. That's going to give you exponential decay. So what do you guys think the tennis ball bounce equation was? Growth or decay?
Okay.
That was exponential decay. For 1, you can tell it's decaying because it's getting smaller, smaller, smaller. Also, the B value is between 0 and 1. So it's exponential decay. Okay, I'm going to try and squeeze in a couple of formulas that you're going to see kind of often, and it's appreciation and depreciation. All right, so we're going to say y equals a. And then to get the b value, what we're going to do is 1 plus r, and then raised to the t. How do you think the depreciation formula is going to be different? Minus, good. It's going to be 1 minus r raised to the t. And then sometimes it's raised to the t minus 1 on both of those. It just depends on what you're given. Like if you're given the thing on day 0, then it's going to be the t. If you're given the thing on day 1, you're going to need to do t minus 1. And I'll show you an example of that in just a second. And then you can always just plug in values and just make sure it's working. Okay, so this billionaire hires you to mow her lawn. For pay, she'll give you a penny for the first job and then double that pay each time you complete the job. So do you guys think this is a good deal or a bad deal?
How many days are we doing it for?
That's a good question. How many times do you think you mow someone's lawn in a season?
It takes forever for grass to grow. And it's hot.
Right.
So it's
Once a week for like,
3 or 4 months.
yeah, for a bunch of weeks.
Maybe twice a week. It would take like 30 weeks.
30 weeks. Okay. 30 weeks mowing. So you what?
If you multiply, if a penny doubles like every time for like a month, so 1, 2, 2, 4, you have like $1 million.
At some point, you're going to have like $1 million. Let's figure out when that is. That's actually part C. So let's just start with how much you're going to make on the third job. So if you give up, you're not going to make very much money. So first job is a penny, 1 cent. Second job, 2. So the third job is 4 cents. Not really worth your time at this moment, but hang in there. It's going to be okay.
How much of the yard do you have to cut? Because I'm only cutting the blade of grass. I really will.
You have to mow her whole yard to get your penny.
Is that what it says?
Yeah.
They don't say that.
All right. So then let's see. We're going to write a formula to represent how much money you make after the nth job. All right. So what should the initial amount be? Penny, which is 0.01. What should the base be in this situation? For doubling the page, 2 is whatever you're multiplying by each time. And then we're going to need to decide if we're going to raise this to the t or if we're going to raise this to the t minus 1. So were you given, is that penny like the 0 job or the first job? It's the first job, so it's going to need to be t minus 1. All right, so let's just guess to see how long how many jobs you're going to have to do before that pay is over $1 million. Does anyone want to take a guess on how many it's going to take? 100? It's not 100. I did 100 last period, and it ended up being scientific notation where it was like 6 and then 27 zeros after that. I don't even know what that number is. So boys, you're going to say 30. So if it's
100 was a lot.
way a lot, like so big, I don't even know what it's called. All right, so he's going to say 30. So what would I raise it to if it was 30? 29. That's a pretty good guess, actually. Although I didn't type it right.
Oh, we're going to be T minus 29 because 29. I'm sorry, y'all.
It would be 30 minus 1, which would be 29. So that's $5 million on the 30th job. So it's going to be smaller than that. So what do you guys want to try next? The 25th. So we'll raise it to the 24. So this was 5 million. This one is 167,000.
That's a huge drop. 5 days.
So it's going to need to be probably a little closer to the 30th day.
27.
So 28th, we raise it to the 27.
Because once you get to like, it would get like 1 mil and then 2 mil, and then you'd be like 6 million the next day. So
Right.
like
So he's good. The 28th day, when you raise it to the 27, you get $1,342,177.28. So it's a pretty good deal. That's a lot of money for mowing. So the 28th day is the day.
How big is a yard, though?
This is a fictional situation, but I would mow 5 acres for $1 million. Would you not?
I would mow 20 acres for $1 million.
Yes. I'd mow for a week for $1 million. You wouldn't?
7 days is big as shit. I don't mind. Is it a push mower or am I on a zero?
It doesn't matter. It's $1 million.
I push mow 20 acres.
You push mow 2 acres.
I push mow 20 acres.
That's crazy.
I'm pretty sure I would too.
It would take a long time.
Yeah. I'd work for that time, and then I'd be like, you know what? I'm done. I'm done working for a long time. I have $1 million.
Yeah, I don't got 7 days ever.
But then, if you make $1 million, you won't have to work again for a long time.
After $1 million is gone, you're gonna have to work again.
But you invest that money and live off the interest. I don't know. Sounds like a good deal to me once you get past the first few days. All right. Anyway, this is not going to happen to any of you, so it doesn't matter. So on number 2, given which of the following scenarios identify, which is exponential growth, exponential decay, or neither. Now, I just want you to know, just because it has a percent in the problem does not mean it's exponential growth and decay. So we have to think about what happens in the problem. So on A, it says you buy a car that loses 20% of its value every year. That's exponential decay. So it has to be continuous. Like it has to keep on happening. It can't just happen once. It has to happen year after year after year. And because it's losing money, that's going to be exponential. Losing value, it's going to be exponential decay. You're multiplying by 80% each year. Okay, and then B, a restaurant job shares 3% of total sales for each shift with its employees. Is that exponential growth, decay, or neither? That's neither. That's like a one-time thing. That's not happening over. It's not 3% and 3% and 3% growing or decaying. It's just a one-time thing. Now C is tricky. So the battery life of your phone decreases by 10% every hour. Is that a percentage actual, or is that like, what is your battery life measured in anyway? It's already percentages, right? And so you start off at 100%, and then in an hour it goes down by 10%, and then in an hour it goes down by 10%. It's not exponential. This is actually linear. It's not going down by a percentage, it's going down by a certain amount every time, which is kind of weird. All right, and then what about D? You deposit money in an account that pays 4% interest each quarter. Exponential growth, exponential decay, or neither? Exponential growth. That's what you want to see. Put that $1 million in there. Keep getting a bunch of interest.
Every quarter, though. So.
Yeah, every 3 months, and then every 3 months.
Like, this is crazy.
Quarter of a year.
Okay.
All right, and then for number 3, I wish I would have changed this problem to not be rats because it grosses me out every year that I do this. But anyway, if the initial population of rats grew, or was 20 and grew to 25 after the first year, which of the following functions best models the population of rats with respect to number of years if the growth of rats is considered exponential? So which ones of these choices is exponential? There's 2 of them that are exponential. What letters? B and C. So A is linear and D is quadratic, so they are not going to be answers. So we need to decide, are you multiplying by 1.25 each year, or are you multiplying by 1.2 each year? So you would need to multiply 20 by one of those two and get 25.
25 and 25. B.
It's B. And anytime you want to figure out that growth rate, you take 1 and you divide it by the previous one, it gives you what that growth rate is. So there's lots of ways to get that answer, but the answer is definitely B.